there is tremendous worldwide demand for raw materials. Driven by booming economic regions around the world, this demand is growing rapidly. The important role played by iron and steel industries means that manufacturers worldwide are facing new challenges. How can the resources necessary for iron and steel production be preserved? How can operating costs be reduced at the same time? How can we accomplish these goals while maintaining plant availability of over 95% and impressive product quality as well? By transforming 3 steps into a single process. Finex technology allows hot metal to be produced from fine-grained ore in just a single step. Process steps such as coke production and the sintering of fine-grained ore required by conventional blast furnaces are no longer necessary. The Finex process reduces emissions such as dust, sulfur, and nitrogen oxides by up to 90% compared to conventional production in blast furnaces. The principle behind Finex technology? 4 fluidized bed reactors arranged in series transform ore fines at about 800 degrees into sponge iron pieces. These are fed directly into a melter gasifier and smelted into hot metal and slag. The 2000-degree heat required is generated by the gasification of coal with oxygen. The resulting mixture of carbon monoxide and hydrogen is fed into the fluidized bed reactor as a reduction gas. This type of iron production generates an additional valuable byproduct in the form of export gas. The gas is recycled to a large degree in the Finex process and can then be used to generate electricity. Finex technology from Siemens revolutionizes iron smelting. POSCO, one of the world's largest steel producers, started operation of the world's first Finex plant in April 2007. The advantages of this technology are clear. Operating costs reduced by 15% per metric ton of raw iron. Investment costs reduced by 20% compared to conventional plants. Emissions reduced by 90%. Reduced energy costs. Finex technology stands for maximum plant availability and impressive product quality.
In close cooperation with the Korean steel producer POSCO, a highly innovative and future-oriented hot metal production process was developed that is known as FINEX. The unique features of the FINEX process can be summarized as follows. Iron making is carried out in two separate steps. In a series of fluidized bed reactors, fine-grained iron oxides are reduced to direct reduce iron, compacted, and then transported to the melter gasifier where melting takes place. At the same time, coal is charged into the melter gasifier and combusted. This provides the necessary energy for melting and for reduction work in the fluidized bed reactors. Viewing the process from the ore route, iron ore fines are pneumatically conveyed to the fluidized bed reactor tower and then charged into the first reactor of a three-stage reactor series. The reduction gas, which is generated in the melter gasifier, flows through each of the fluidized bed reactors in counterflow to the ore direction. The fine iron ore is fluidized by the gas stream and increasingly reduced in each reactor step. In the exit area of the final fluidized bed reactor, the reduced iron is compacted to so-called hot compacted iron. This is followed by the transfer of the hot compacted iron to the top of the melter gasifier by means of a hot transport system. From there, it is directly charged into the melter gasifier, where final reduction and melting take place. Viewing the process from the coal route, non-coking coal is directly charged into the melter gasifier through a Lockhopper system. A new feature of the FINEX process is the simultaneous charging of hot compacted iron and coal by means of charging screws and the use of a gimbal top charging chute. The gimbal top allows an exact distribution of the burden within the melter gasifier to be achieved. After the coal drops onto the top of the charge bed, degassing takes place. The released hydrocarbons are immediately dissociated to carbon monoxide and hydrogen. This is due to the high prevailing temperatures that exceed 1,000 degrees Celsius in the dome of the melter gasifier. Oxygen injected into the lower part of the melter gasifier combusts the coal. This generates both the heat required for melting work as well as a highly valuable reduction gas comprised mainly of carbon monoxide and hydrogen. This gas, which exits the dome of the melter gasifier, is cleaned in a hot gas cyclone before it enters the fluidized bed reactors. Following melting of the direct reduced iron, the tapping procedure is carried out exactly in the same manner as in standard blast furnace practice. FINEX hot metal is identical in quality to excellent blast furnace hot metal. Another valuable byproduct of the FINEX process is the clean export gas that exits the top of the fluidized bed reactors. This gas can be used for a wide variety of applications, such as the production of additional direct reduced iron in a separate furnace, synthesis gas for use in the chemical industry, as well as for the generation of electrical energy. The benefits of the FINEX process are decisive. Direct use of low-cost fine iron ores. Direct charging of low-cost non-coking coal. Generation of a clean export gas for a wide range of downstream applications. Production of hot metal in a quality identical to blast furnace hot metal. Proven environmentally friendly hot metal production. FINEX, the iron-making solution of the 21st century.